All right, so let's just try, it's going to be implicit differentiation. I don't know, 2x cubed plus 3xy plus y squared equal to 20. So the one you guys have on tomorrow's test is similar. Not identical, but similar. Now remember, we're going to do this with respect to x, right? It's always d dx, unless they say otherwise, but something in terms of d dx. So I'm going to take derivative of both sides with respect to x. So this is not a step you have to show, it's just a step I'm showing you, what we're doing. Now, when you take your derivative, it's going to be with respect to x. That means anytime you take a derivative of an x variable, you do not have to show implicit differentiation notation. So the 2x cubed is going to become 6x squared, and that's about it. I'm going to leave that the way it is. Plus the 3, I'm taking the 3 out because I know 3xy, that's a product. I don't need to have the 3 inside of it, so I'm going to take it out. And I'm going to take a derivative of the product of x times y. Okay? So the derivative of x is 1, right? I'll show it here, times y, plus x times the derivative of y is 1. That would be dy dx. So there's the product rule for xy. And then the derivative of y squared is 2y dy dx. That's equal to 0. At this point, you're going to distribute and try to combine your dy dx's. So we have 6x squared plus 3y plus 3x dy dx plus 2y dy dx equal to 0. So before I move on, are we good with this right here? Any questions on this? We can call it like step 1, 2, 3 here. Everybody good? All right, so we're going to try to isolate dy dx. So let me move the 6x squared over to the right side. And at the same time, I'm going to factor dy dx from the 3x and the 2y terms, okay? So the 6x squared minus 3y, is going to go to the right. And I'm going to factor out dy dx from 3x and 2y. So this will be negative 6x squared minus 3y. All right, now to get dy dx, I'm just going to divide everything by 3x plus 2y. So dy dx is negative 6x squared minus 3y over 3x plus 2y. And that's going to be your solution. Step 4, step 5. Questions on this? Steps 1 through 5? Concerns? Yeah. What else do you guys want to see?
Find y prime if y equals cosine to the fourth power of 3t.
All right, so let me write that down really quick. So number 2 here, you said find y prime
if y equals cosine to the fourth power of 3t.
So take the derivative of that. Okay. So it's obviously not 3x, so normally it's xy, but there's going to be ty. So y prime means the derivative of y, right? So I'm going to do dy dt because there's no x, right? Normally I do dx if it was in terms of x, but this is in terms of t. So it's going to be dy dt. All right. Cosine to the fourth of 3t. If you want to write it out differently, you can also write it like this: cosine of 3t to the fourth power. You don't have to do that, but I'm just trying to make it a little more obvious that you have a power on the outside. That's the overarching function, is your fourth power. Okay? And then inside of that is your cosine function, and inside of that is a linear function of 3t. So when you do this problem, let me rewrite this in red, sorry, dy dt. Or if you don't want to write dy dt, just write y prime of t. That would be okay too. But I'm just going to do dy dt. I'm going to bring the 4 down. That's going to be cosine of 3t to the third. Remember, anytime you do chain rule, the first thing you do is power, and then you start with the chain. So I drop the power rule down, so the 4 goes down, subtract by 1, I get a power of 3. And then I have to take the derivative. I'm going to show you the work, okay? ddt of cosine of 3t. That's going to be the next step. I'm just showing it to you guys. I normally don't. I just go ahead and do it, but just to show you what's coming up next. So this is 4 cosine cubed of 3t times the derivative of cosine of 3t. Well, first, what's the derivative of cosine? Negative sine of 3t times ddt of 3t. Again, I'm showing you the steps, okay? I'm showing you the steps of the chain occurring, all right? So now I got to do the derivative of the innermost function, which is the 3t, okay, my linear function. So that's going to be, the derivative of 3t is just going to be a 3. I haven't joined anything out yet, okay? So there's everything worked out completely. I just got to put everything together. So this is going to be a negative 12 cosine cubed of 3t sine of 3t. Now that could be the answer. I don't know if that's the answer they would have given you. They could have also used a trig identity and done something with this because, so this is good, okay? This is where I would expect you guys to probably get to. But sometimes in the books, they're going to say, well, I can rewrite this as negative 6 cosine squared of 3t times 2 cosine of 3t sine of 3t, which is negative 6 cosine squared of 3t. Remember the double angle formulas that we talked about? This would be a sine of 6t. That comes from this. Okay, this is why, like I said, it's good for you guys to know and know your identities, because if you know the identities, if they wrote this answer for you guys, if they did, you'd be able to figure out where the sine of 6t came from. Like, why did that happen? That's just double 3t, double your angle, right? So that's just a definition. Now, I'm curious, was this an even or an odd problem for you?
Oh, no, it was just an example.
Oh, okay. But yeah, if it was odd and you would have looked, they may have put that answer way at the bottom, and you might be like, where did they come out with that stuff? But they just use an identity. That's all. But I would be totally okay with this one right here. This is perfect. Okay? It's good for you guys to know those identities, though, because sometimes they're useful. Is that okay? Did that make sense? Like I said, I did it step by step. Normally, I don't. Okay? Normally, when I'm doing this, I look at the very top right, let's say the very top right, and I'll say, okay, 4 cosine 3t to the third times the derivative of cosine is negative sine 3t times 3, right? I just do times. I don't even bother because it takes too long. But when I first learned this, I did take all those steps because I had to get used to like, okay, there's things inside. So I got to work slowly through it, right? But now at this point, 20 plus years later of going over this, I just do it all in one step. Okay.
Why do you sometimes like take away like multiply by cos 3t by the cos 3t and then like another one like negative sine 3t by 3t?
So you're wondering how did I get from this step here, so let's call it step 2 to step 3, right? Like why did I put or I guess you're saying step 1 to step 2.
Yeah, like where'd you get those extra numbers like cos 3t or 3t?
This stuff right here.
Yeah.
It's because, remember, to do the chain rule, you have to first, well, in this case, there's 3 embedded functions, or there's 3 functions, okay? And you can see it right here. The parenthesis to the 4th, that's your big function, the 4th power. Inside is cosine of 3t. But cosine is a trig function. Its angle, normally it's supposed to be like cosine of x, cosine of t. But the angle is now a linear function, 3t, like 3x, right? Y equals 3x is a line, right? So that's the same thing. So I see a 4th power function. Inside of it is a trig function. And inside of the angle for the trig function is a linear function. There's 3 functions. So when I take a derivative, I got to take a derivative of all 3 functions. Okay? So when I take the derivative of the outer function, the 4th power, that goes down, right? Becomes a power of 3. So I took care of my 4th power. Now I got to take a derivative of the inner function. That's why I put, okay, ddt of cosine 3t now. That's my next step. So I took the derivative of this power right here, okay? That happened right there. But I haven't touched this. I haven't messed with that yet. So I say, okay, now it's your turn. Now we're going to take a derivative of the inside. So I write it down, ddt cosine 3t, right? Telling me this is my next step. When I take the derivative of cosine of 3t, that's right there. But notice I didn't take the derivative of the angle. I just did the trig function. Cosine becomes negative sine. But I ignore the angle because the angle itself is its own function. So I get to do that next. So I got to say, okay, now the next step, right? So first I do the outer one, and then I take the derivative of the inner. But then when I take the derivative of the inner, there's even an inner function in that one, right? The linear function. So I got to do the derivative of that too, right? So it's going in step, outside in. The hard part of the chain rule is you have to be able to notice that there's more than just one function there. Like I see 3. Some people just see 2. They see the power and they see the trig function, but they ignore the angle. The only time you can ignore the angle is if it looks like this. You can ignore the angle right there. Because what's the derivative of x? It's 1. So who cares? If I put times 1, what does it matter? Right? So the derivative of this would be, well, this is a power of 2, right? So bring it down. 2 sine to the first x. I'm not going to write that. That's kind of ridiculous. And then what do I do? Times ddx of sine of x. That's my next one. Because notice the first thing was just power. I didn't do anything else, just the power. Right? Derivative of sine is cosine. 2 sine x cosine x. Your next step is the derivative of the angle, but the angle's x. So it's just 1. So you don't have to. If you want to, you can. You can show it. Times 1, right? And this becomes 2 sine of 2x trigonometrically, right? This is an identity. But that would be your answer for that one. But notice, if it's just x, it doesn't matter. If it's anything other than x, you have to do it. So, example. Okay. So that's three functions. The bigger function is, sorry, let me write that out. X cubed squared. The bigger function is your quadratic. Something squared. Inside, cosine. And then inside of cosine, x cubed. So if you were to take a derivative of this, okay, if you want to do d dx of cosine of x cubed squared, you bring down the power, cosine of x cubed to the first, right? So I don't need that. And now move in. So what's next? Cosine. What's the derivative of cosine? Notice I didn't ask you about the angle. I just said the trig function, right? Now, what's inside of the trig function? X cubed. What's the derivative of that? That's how you do it in one step. Just ask yourself, okay, going in, going in, going in. Okay? There's my whole derivative. Now I just got to put everything together. So it's going to be negative 6x squared sine x cubed cosine of x cubed. I can rewrite that in trig with the trig identity, but I'll just leave it alone. Does that make sense? Okay, outside in. Outside in. And if you ever doubt yourself and it just says, say, cosine of x, go ahead and take the derivative of the x. It's not going to do anything bad. It's just times 1. Right? Just don't write 0. Right? That's only for numbers, right? Derivatives of constants are 0. Okay, why? Because a constant, the graph is flat. The slope of a flat graph is 0. The derivative of a constant, meaning the slope of a constant, is 0. So, makes sense. Any other type of question you guys want me to go over? Homework question, random topic?
So, when you look at an equation,
Uh-huh.
you always look to factor out first.
Yes. 99% of the time I do try to factor first. But it depends on what the problem is asking me. Because if they want me to take a derivative of a fraction, I can do that using a quotient rule. But if I can factor stuff out and cancel things out and make that fraction become just a polynomial overall, it's so much easier to take a derivative of a polynomial like x squared plus 2 instead of x squared plus 2x plus 1 over x minus 3. Like, that's a lot harder, a fraction. So if I can cancel stuff out, I will definitely do that. Because when you can cancel things out, you create equivalent functions. And taking derivatives of equivalent functions result in the same answer anyway. So the easier you can make it for yourself, the better. So yeah, I would always factor if possible. Again, depending on the instructions, but about 99% of the time I will usually factor. Just to make my life easier.
For the test, there won't be questions on 2.1.
By that, are you asking me the original definition of the? No original definition problems. I will tell you that. But see, make sure you guys still know it, because when we get to practicing for the AP, those questions do come out. So you can't just be like, he didn't test me on it, so it must not be important. Like, there's a lot of stuff I'm not going to test you on, but it's all still important. So you'll see it when we start practicing. But for the test, yeah, no definition. At least I don't think I saw it, but yeah, no definition.
Did you go for a free-falling problem?
Free-falling word problem. All right, do you got one for me, or do you just want me to make it up? All right. Now, if it ends up messing up gravity, then it's not my fault. Okay. Making up problems is never a good idea. Well, in Algebra 1 and Algebra 2, it's easy. In calculus, I don't know. All right, so let's assume you're standing on, what do you want me to do with it? Do you want me to find velocity of something? Do you want me to find out how long it takes? Oh man, those are going to be really hard, because that means I got to be able to have something that I can use Desmos. Okay. All right, so we're going to assume you're on top of a building. Let's say the building is, someone give me a height. 360? Is that what you said? 36 feet of a building? Man, that's going to be a really fast problem. Let's go with 360 feet. Let's multiply it by 10. So building is 360 feet. How do I denote that? If the height of the building that you're standing on is 360 feet. Remember the notations, right? S of t. So, okay. Did you get my message?
About Wednesday?
Yeah.
Yeah, I moved it to Friday,
Okay.
the 13th.
So it went back.
Yeah, went back.
All right. Awesome.
Yeah,
Thank you.
That's with Oscar though.
Okay.
Yeah.
I don't know, what is this thing? SAT. Are your English teachers making you guys write that stuff out before? I just realized I should have paused it. I'll edit this. Don't worry. So it doesn't have that whole thing out there. All right. So remember, let's say feet. We said feet, 360 feet. So it's going to be negative 16 t squared plus v naught t plus s naught. Okay. So if I said that the building is 360 feet, where do I put that? S naught, right? So S naught is 360 feet. For the sake of simplicity, let's say you dropped the ball. So if you drop the ball, what's your initial velocity? 0. Okay. So let's fill that in. S of t is equal to negative 16 t squared. V naught is 0, so the middle term is going to disappear. So 360. So how long does it take to hit the ground? What is this for? Period absence audit. Ooh, I would have to. I'll take. Is this for Miss Chavez?
Yeah.
Okay. Can I go take it up to her for your next period? Just tell her I'll take it up because I gotta double check this. Thank you. Yeah, that's attendance. I can't just sign it blindly because that's a legal paper. So I want to ask you how long it took to hit the ground. Okay, how long did it take to hit the ground? So what do I do? So let me put right here. How long to hit the ground? So what do I do to this equation? Well, I don't need velocity. Make it equal to 0, right? My final height has to be 0, right? So 0 equals negative 16 t squared plus 360. We'll move the negative 16 squared t squared over. We'll divide both sides by 16. And then take the derivative of it. I'm sorry, not derivative, I'm sorry, square root. So we're going to take the square root. But notice when I take the square root, I'm not going to do plus or minus because time can't be negative. So this will be the square root of 360 over 16. I don't have my calculator with me, so this is a 4. It's 36 times 10, that's 6 radical 10. So t is equal to 3 radical 10 over 2, which I'm sure is an amazing number. I don't know what it is. Anybody have a calculator with them? Give me this estimate. I mean, what's the square root of 10? It's a little bit over 3, right? 4.74? All right, thank you. That's where it ended, 4.74?
There's a bunch more.
All right, I always need 3 numbers. Round to the 3 numbers after the decimal.
So 7.3.
743. All right. Yeah, either round or don't round, but give me 3 numbers after the decimal if there are enough numbers. Okay. So that's how long it takes to get to the ground. So now the question is, how fast was it moving when it hit the ground? Okay? So now, to figure out speed, what do I do? Now I'm going to want to do what you told me to do at first. Find my velocity, right? By doing a derivative, right? I want to take a derivative of my position function. So v of t is equal to, so how long did it take? There you go. Okay, I'm going to put how fast was it going. That's going to be this part right here. Okay, so how fast was it going? The derivative of velocity, the derivative of s of t, to find velocity, we take the derivative of position. So the derivative of position is negative 32t plus 0. So all we got to do is plug in a 4.743 into that equation. So negative 32 times 4.743. And my pen decided to take a nap. So let me pause this really quick. So plugging in 4.743 negative 155.776. This is feet per second. Okay, remember velocity, just like when you go driving on the freeway, right? They have miles per hour, right? That's the velocity that you're supposed to be going. Actually, it's speed. How many of you guys are taking physics? So just a couple. You guys make sure you know speed and velocity are two different things. Okay? Speed is a number with no direction. Velocity is a number with direction, right? So that's why they say speed limit, because it doesn't tell you which direction you're moving. You're just going that fast, right? But if we wanted to write velocity, maximum velocity limit on the freeways, the 10 freeway would say 65 miles per hour east and 65 miles per hour west. Okay, that would be the velocity. Speed doesn't require east or west. So that's why they just put a number there. For those of you guys that are not taking physics, don't worry about anything that I said right now. It's just related to that. But anyway, so there's your velocity for this thing. That's how fast it was going when it hit the ground. This right here is how long it took to hit the ground. I mean, we could obviously throw the ball upwards and then our initial velocity would exist. The reason why I didn't do that is because if I put an initial velocity in, then I got to make sure that I have a quadratic function that can actually factor or that actually lands in the right place. And if I end up putting everything on the quadrants 2 and 3 by accident, that means time is negative, and that's not good. So, yeah, it's sometimes a little scary to create problems in calculus because you got to make sure it works first. So I made sure it worked. I knocked out the middle term, and that'll usually result in a positive result.
Number 47 of 2.5.
Do you know what number 47 2.5 is? Because I don't have it in front of me. I can get it. If you don't know it, I can get my book. I just don't have it out. If you're looking through your phone, let me get my book. Does anybody have it on them? 47 2.5. All right. What page was it? Anybody know?
146.
146. All right. Number 47. Find the second derivative in terms of x and y. So 47, x squared minus y squared equals 36. If I'm correct, this is a hyperbola, right? The same AB value. So, all right, so they want me to take the second derivative. So first derivative, we're going to have to do it implicitly, okay? So first derivative, I'm doing ddx. Okay, how do I know I'm doing ddx? Because the instruction says to find dy or d squared y dx squared, meaning the second derivative. So notice on the bottom it says dx squared, right? So with respect to x. So I'm doing this with respect to x. So the derivative of x squared is 2x. I don't need to write dx dx, okay? Minus y squared is 2y dy dx equal to what? 0, right? I got to solve for dy dx, so let me move over the 2x. So I get negative 2y dy dx is equal to negative 2x. And I'm going to divide everything by negative 2y. So when I do that, I get dy dx is equal to x over y. Are we okay with that first part? So next is the second derivative, okay? Which means I'm going to take dy dx and I'm going to do d dx of dy dx, meaning, this is going to sound weird, but I'm doing this. The derivative of the derivative, okay? D times d is d squared, and then y, over dx, right? Squared. So it's dx squared, like the whole thing. That's how they get that notation, okay? So I'm going to take the second derivative of it. So d squared y dx squared is, now it's already set up for me as a derivative, right? The derivative is x over y. So let me just take the derivative of x over y. That's a quotient rule, right? Quotient rule. So what's the derivative of x? 1. I don't need to write dx dx. So 1 times y minus x times the derivative of y is 1 dy dx over, what am I supposed to put on the bottom? Y squared. All right, let me clean this up really quick. Y minus x dy dx over y squared. Are we okay so far? Just doing the quotient rule? All right, but I'm not done because they don't want me to leave it like that. What's dy dx? It's x over y, right? That's right here. Dy dx is x over y. So instead of dy dx, I'm going to write x over y. So y minus x times x over y over y squared. From here on now, this is just algebra, tricky algebra, I guess, but this is y minus x squared over y squared. I can combine the top part, y minus x squared over y, if they have the same denominator. So this will become y squared minus x squared over y squared divided by y squared. Okay, let me explain that. I don't know if you need me to explain it, but I'm just going to explain it. In order to combine this with that, they have to have the same denominator, right? But the only way that y can have the same denominator as this is if I multiply this by y over y. So this becomes y squared over y. So if you want, I'll show you that step. It becomes y squared over y minus x squared over y. That's what this is. So then when I combine it, it'll be y squared. I don't know why I put y squared on the bottom. My bad. That should just be a y. Just a normal y here. So it should be y squared minus x squared over y. Okay? Right there. And now I'm going to combine these two. A fraction divided by, if I may, a fraction is a product of a reciprocal, correct? So it's just this times 1 over y squared, which results in, here's your answer, y squared minus x squared over y to the third. And this is your answer. Questions? Zoom out a bit. This hard part that you basically see, this is all algebra, okay? So don't blame calculus if you're having trouble with that part. That's algebra, okay? You can blame calculus for the step on top and anything above that. But the part after that, that's algebra. Okay. Tough algebra, but algebra nonetheless. Anybody need me to explain anything on that whole process from beginning to end, anything like that?
Why is it Y cubed?
Say it louder.
Why is it Y cubed?
Why is it y cubed? It's because a fraction divided by a fraction, you get that top fraction and you multiply it by the reciprocal of the bottom fraction. So y squared over 1 becomes 1 over y squared. So then when you multiply it, the denominator y times y squared becomes y cubed. Any other questions on that one? I'm curious, was the reason why you had me do this because you wanted to see how I did it, or was that the answer that you saw made no sense?
Because the answer in the book came out as 4 over y cubed, and I don't know where that comes from.
They wrote 4 over y cubed?
Yes.
Did they? Hold on, let me see if they try to get all cute with something. Hold on, what is it? X squared. X squared is 36 minus y squared. I'm wondering if maybe what they did is they said, oh, since x squared minus y squared is 36, right? So then this, if you take out a negative, let me just play with this really quick. Again, this is why I don't like solutions manuals a lot of times. Correct? I can factor out a negative from the top and it makes it x squared minus y squared. But what's x squared minus y squared defined as? 36. So this could be negative 36. So, I mean, this is another option for your answer. I mean, I can get as creative as I want to. There's a point though where you're like, okay, I'm just being mean, right? By changing little things around, right? This is where I would hope to get to, the big box. Okay, that's where I would like you to do. I don't want you to stop right here because you're not done. Okay, I'm sorry. This part up here. I don't want you to stop there because dy dx, you know what that is. That's x over y. So plug it in. Okay, but yeah, fix it. It's just algebra. From there, it's just algebra. You guys should be able to do it. Okay? And if you're not, come and see me so we can practice it. We can try to fix it. But yeah, I've always told my calculus classes, usually by the time you're taking the AP test, it's never the calculus that messes you up. It's the algebra that makes you make mistakes. Your algebra is not strong and you make bad factors, you forget to factor, you add wrong, rewrite things incorrectly, you switch signs when you shouldn't. It's those little errors that you don't expect to make. You think you're going to mess up in the calculus, but by that time you're pretty decent with it. And then you start realizing, like, man, calculus is like this much of the problem. The rest of it is all algebra, right? And that's where I messed up in the algebra. So usually it's the algebra that's going to mess you up. Usually. But, I mean, obviously you can make calculus mistakes. But yeah, just be careful. Anything else? We got 4 minutes. Is there something else just of concern that I can try to clear up? Yeah, I kind of told you what's going to be on it. There's a little bit of everything, but there is not going to be a definition, a limit definition. Okay?